Okay, welcome back. While I was waiting for that to upload, I made a discovery that I wrote the two numbers down in the wrong spots. You probably already discovered this. This one is 46,080, and this one is 96,0. And so over here, this is really, the one I'm breaking into components is 4680, and this one is 96. So this is 4,680, and this one is 4,000, or whatever this number is that I'm filling in. Okay, and so I found the right components while we were gone. So 27 and 36. All right, and so now the x, now you have to do, so the sine and the cos, we get the components. Now we have to add the two x's together. So the 36,000 and this 36,000, and when you do, you get 72,863, and the y's are going in the opposite direction. And so you have to subtract them. And remember, you had 96,000 going down. This is a 0, so this is really 96,000. And we're going to subtract from that the 27. And when you do, you get 68,351.934 newtons per coulomb. This is down, and this is to the right. Okay, so now you do the last step, which is to the right and down. And they're pretty much the same length. 72 is a little bit bigger, 3.95 newtons per coulomb, and this one's 68,351.9, etc. And you're going to square them, add them together, take the square root, and find the E at the fourth point, and it is 99,905.667 newtons per coulomb, and this angle is going to be 46 point, nope, I found the other angle, because this should be smaller, so it should be 43.17 perhaps degrees, and that should be clockwise from the positive x. I got a 46, so I must have done the drawn it down and over. Okay, so I have a feeling on the paper that angle might be backwards. The last part, C wants potential difference. So remember, V total is equal to V1 plus V2 plus V3, and we're going to find it at the fourth corner again. And so you're going to do V1, which is KQ1 over R, V2, which is KQ2 over its R, and V3, which is KQ3 over its R. So 9 to the 9th Newton meters squared per coulomb squared, 8 times 10 to the negative 6 over its R was 1.25. This one, 9 to the 9th Newton meters squared per coulomb squared, negative 6 to the negative 6, and this one was 0.75. R's are not squared this time. And 9 to the 9th Newton meters squared per coulomb squared, what was it, 4 to the negative 6, and 1 meter. So when you do this, you get 36,000 again, volts. You get negative 72,000, I think I have it in the right order this time, volts. And you get 57600 volts, and when you add them up, 21,600 volts. Okay, so that's number 24. All right, you asked for a torque ladder. I don't really have time because my next one's starting, but I can at least talk about it for a couple of minutes. Friction at the top. So, oh wait, I haven't started. So if this is our thing with our friction at the top, when you do the sum of the forces in the y direction, which is going to be equal to 0, you're going to have F normal of the ground going up plus friction of the house minus Fg of the ladder minus Fg of the person equals 0. Okay, in the y direction, and usually we still solve for friction of the normal of the ground. So take the others over. So m of the ladder G plus m of the person G minus friction of the house. And then the sum in the x direction is still going to be normal of the house minus friction of the ground equal to 0. So the normal of the house will equal the friction of the ground. Okay, so when you go up here and do your torque, so there'll be a friction from the normal of the ground, but we'll pick our pivot point there, so it'll go to 0. A friction, torque from the normal, friction of the ground, it'll go to 0. Torque from the normal of the house will keep. Torque from the friction of the house will keep. Torque from the ladder, a torque from the person. Clockwise and counterclockwise, both of these will be positive, these will be negative. So it'll be R normal of the house, F normal of the house, sine theta normal of the house, plus R friction of the house, F friction of the house, sine theta friction of the house, minus R of the ladder, M of the ladder, G, sine theta of the ladder, minus R of the person, M of the person, G, sine theta of the person. Okay, and that's going to equal 0. Now, the only place you sub is right here. Friction of the house is equal to mu of the house, F normal of the house. Okay, sub that in right here, and then solve for friction, normal of the house. It'll be your only unknown. Once you get normal of the house, you can go back to your forces. Okay, so you're going to pull this normal of the house out, and so it'll be R normal of the house, sine theta normal of the house, plus R friction of the house, mu of the house, sine theta friction of the house, and all these guys, the R of the ladder, M of the ladder, G, sine theta, etc. Divide by this stuff, you know all of it, you know the R's, get the F normal of the house, and then go back to your forces. Okay? Sorry I can't complete it, but I have to run because there's another class. Thank you, and see you tomorrow. I'll put a message in the group later tonight telling you to go to bed.